So we're going to continue with section 3-4, and the first thing we're going to talk about are complex conjugates. So if you have the complex number a plus bi, then its conjugate is a minus bi. Basically, you just change the sign on the imaginary part. So if you multiply a complex number by its conjugate, here's what ends up happening. So I'm going to go ahead and use FOIL. So I'm going to do the first, or get a squared. And then the outer, I get minus abi. And then the inner, I get plus abi. And then the last, I end up getting minus b squared I. I can cancel out these terms right here. And remember that I squared is -1. So I'm going to replace I squared with -1. So I end up getting a squared, and then minus a minus turns plus b squared. So this right here, there's no imaginary number with it, so this is a real number. So one of the biggest things, or the most powerful things for a number and its conjugate is when you multiply them, you'll always get a real number. So a numerical example would be to take 2 plus 3i and multiply it by its conjugate. So all you need to do is change the sign on the imaginary part. So it would be 2 minus 3i. Oops. There we go. And then we're going to multiply that by 2 plus 3i. So I'm going to go ahead and FOIL this out. So first, I end up getting 4. Then the outer, and I end up getting plus 6i. The inner is minus 6i. And then the last is minus 9i squared. So the 6i's end up canceling out. The I squared is going to be replaced with a -1. So basically I get 4 plus 9, or 13. That formula right here, if I know what a and b are, I can just square it. So a is 2, and b is 3. I could have just done 2 squared plus 3 squared to get the result really quickly. And that will always work when you multiply a number by its conjugate. So the next concept is dividing complex numbers. And what you're going to do is you're going to multiply the numerator and denominator by the conjugate of the denominator. So here's an example. So I have 5 plus 6i over 1 minus 3i. And one thing for you to note is that you can never have an imaginary number in a denominator. It's not considered to be simplified or proper. So we want to get rid of it. And if you remember, the only way to get rid of a complex number is to multiply it by its conjugate, because you get a real number. So in the denominator, I'm going to multiply by 1 plus 3i. Now remember, whatever you do to the bottom, you have to do to the top. This is like multiplying by a 1 right here. So I'm going to go ahead and FOIL this thing out, top and bottom. So I'm going to put my parentheses here, and I'll do the top first. So starting here, I'll end up getting 5. Here I get plus 15i. Here I'll get plus 6i. And the last, I end up getting plus 18i squared. Alright, the denominator, I can use the little shortcut if I want. It's a squared plus b squared. That's a and that's b. So I basically get 1 squared plus -3 squared, and I end up getting, what is that, 10? The numerator, I can go ahead and simplify. I'm going to go ahead and replace I squared with -1. So I end up getting 5 minus 18. So I end up getting -13, and then I can go ahead and add these two right here to get plus 21i. So you can leave the whole answer under 10, or sometimes the book actually separates the real part and the imaginary part. So they'll write it as -13 plus 21i over 10, just so you can identify the real part and the imaginary part. This would be the real, and then the 21/10 would be the imaginary part. So we're going to go ahead and square root negative numbers this time, and you're going to simplify the square root as if it was positive, and then you're going to add an I to the answer. That's the only difference, because you can't take a square root of a negative number. You start going into the imaginary numbers. So let's go ahead and start with this example. Square root of negative 36. Well, what you can do if you want is you can go ahead and break it up into the square root of 1 times the square root of 36. And you can say, oh yeah, the square root of negative 1 is I, and the square root of 36 is 6. So this is the same thing as 6I. Or you can use the hint that I just told you. So you just simplify the root. What's the square root of 36? It's 6 because it's negative. Tack on the I to it. For this example, the square root of negative 5, you can't simplify root 5, so all you would say is this is I root 5. In this example, you're asked to simplify this expression, and usually what I like to do is simplify my roots before I actually FOIL. So I'm going to go ahead and simplify the square root of 63. Its factors are 9 and 7, and I can root 9. So this is the same thing as 3 root 7 minus, and then this is, because it's negative, is imaginary, so I'm going to get minus I root 7. And then I'll get 7 plus, and then the square root of negative 9. Well, square root of 9 is 3, but because it's negative, it's imaginary. So I'm actually FOILing out that. So I'm going to go ahead and distribute this out. So when I end up doing that, I'd multiply the real parts. So 3 times 7 is a 21. And then I have the root 7. And then I'm going to distribute this here. So the 3 times the 3 is a 9. And then there's an I. And then I have the root 7. And then distribute that out. I get minus 7I root 7. And then last but not least, I have a negative 3I squared root 7. So replacing my I squared with a negative 1, this basically right here comes out to be plus 3 root 7. So when I combine like terms, my real parts I combine, so they have root 7 in common, so 21 plus 3 is going to give me 24 root 7. And then when I combine my imaginary parts, these two guys right here, I get plus 2I root 7. So that would be this expression completely simplified. The last concept is quadratic equations with complex solutions. Pretty much if the quadratic does have complex or imaginary solutions, it's not going to be factorable. So whenever something is not factorable, you're going to have to use the quadratic formula. So here's an example. So you're asked to solve this quadratic, and most people generally start by trying to factor it, find two numbers that multiply to 5, add to 4, and you try 5 and negative 1, that adds to 4, but it doesn't multiply to 5. So it's not factorable. I told you anything with an imaginary solution isn't going to be factorable, so you got to go right to the quadratic formula. So you have A is 1, B is 4, and C is 5. So I get opposite B plus or minus the square root. B squared is going to give me 16 minus 4A, and C is 5, all over twice A. So when I go ahead and simplify, I end up getting inside the square root 16 minus 20. So that would come out to be negative 4 plus or minus the square root of negative 4 all over 2. And the square root of negative 4 simplifies into 2i. So I get negative 4 plus or minus 2i over 2. And remember, when we simplify, that denominator has to simplify with both in order to reduce. So I end up getting negative 2. Let's try that. Negative 2 plus or minus I. So you have imaginary or complex solutions. What does that mean in terms of the graph? Well, if I were to sketch this, I would get 1, 2, 3, 4, 5. If I plug in 0 everywhere there's an x, I get 5. Plug in some more numbers, my quadratic would end up looking like this. And because I have imaginary, remember these are zeros, what you're finding when your equation is equal to 0. Zeros are x-intercepts. Because they are imaginary, What that means is that this parabola, this quadratic, never crosses the x-axis, thus the imaginary solutions. Alright, that's a wrap. I'll see you tomorrow.